Let's talk about the ocean. It's massive, beautiful, and full of life. But did you know it's quietly undergoing a chemical change that affects the tiniest of plankton to the largest of the coral reefs? When we burn fossil fuels like coal, oil, or natural gas, we release a lot of greenhouse gases into the atmosphere, including carbon dioxide, or CO2. But carbon dioxide doesn't just stay in the atmosphere and in the air. It can turn into acid rain, or it can get absorbed by the ocean. When CO2 enters the ocean, it reacts with ocean water to form carbonic acid. Yep, that's right, acid. That's H2CO3, if you like formulas. But here's where things start to shift. Carbonic acid doesn't stay whole for long. It breaks into hydrogen ions, or H plus ions, and bicarbonate ions, or HCO3 minus ions. The hydrogen ions are little troublemakers. They actually lower the pH of the ocean, making it more acidic. Here's the issue. Many marine organisms like coral, mollusks, and sea urchins need carbonate ions in order to build their shells. But those extra hydrogen ions, they team up with carbonate in order to make bicarbonate. The more bicarbonate we have, the less carbonate ions are left for shell making. The result? Weaker, thinner shells, less calcification. Corals struggle to build their reefs. Some sea urchins grow much slower in more acidic water. Like the pencil urchin, for example. When it was raised in more acidic conditions compared to other sea urchins, it grew much less and remained much more small than its counterparts who were in less acidic conditions. Interestingly, not all species react the same. When lobsters were exposed to more acidic conditions, they actually grew more quickly than their counterparts. So responses can vary, but overall, for the most part, it is a negative. Since the Industrial Revolution, ocean pH has dropped from 8.2 to 8.1. Now, that might not seem like too much of a change, but you have to remember, pH is measured on a logarithmic scale. So going from 8.2 to 8.1 actually represents a 30% increase in acidity in the ocean. And if we stay on our current path, we can expect the ocean pH to drop to 7.8 by the year 2100. Anthropogenic, human-caused activities like burning fossil fuels and deforestation are kind of driving this change. But it's not just CO2. Burning coal and gas also release other pollutants like nitrogen and sulfur oxides that contribute to acid rain and more acidic conditions. But here's the good news. If we understand the problem, we can be part of the solution. Reducing our emissions and protecting our oceans can preserve the amazing biodiversity that we have there. Ocean acidification. It's real, it's happening, and we can do something about it.